It's now my turn to introduce Professor Giulio Sandini to give the last keynote speech of this edition of ICDL 2025. It's a pleasure for me to introduce him, but it is also a challenge, because given everything he did in the past, and most of you know it, it's difficult to handpick what to present in a 1-minute presentation. So I decided to pick just 3 moments that for me personally were transformative. So he's a bioengineer, first of all, as I am, and he started the Lira Lab in Genoa to demonstrate and open the eyes to a lot of students in bioengineering at the time of the fact that robots are not just cool things that you could imagine of building, but that by building robots, you can have a new, very useful tool to understand cognition. This was the first step that then he embodied by actually coordinating the Robot Cup project in 2004. A very big, very international project where they actually tried to take inspiration from an intelligent system, the baby, to build an intelligent system, and vice versa. By building such an intelligent system, try to understand human and our incredible ability to learn. And this led to the creation of the iCub robot that now is in more than 50 institutes all across the world. And later on, he moved on being one of the founding directors of the Italian Institute of Technology and of the Robotics, Brain and Cognitive Science Department, where several of the people in the audience actually grew, where he actually gave a demonstration that it is actually possible to create a multidisciplinary place where people coming from different disciplines can live together, work together, and build something new. So without further ado, I leave the floor to Professor Giulio Sandini.
Well. Thanks. Thank you, Alessandra. Maybe I should go away now and leave you with this very, very nice introduction by Alessandra. And well, first of all, thanks to the organizers. You always say this when you are invited someplace, but ICDL to me is very close to my heart, and I feel the environment very much. And this morning I was walking here, and they are cutting the grass outside, and I can smell the grass just cut, which is an emotional smell for me. I don't know about you, but I mean, every time I feel it, I remember when I was a kid and playing and cutting the grass with my father and so on and so forth. So ICDL is not only a scientific conference for me; it's also a personal, emotional place to be, and that is. And that is the reason why I thank the organizers, not only once, but twice and many more, about that. So, and thanks for being here this morning, because yesterday we were in a magnificent place on the rooftop overlooking Prague, and we had nice food, nice drinks, and nice company. We discussed and talked about personal and scientific issues. So thanks for being here early in the morning. So about ICDL, my participation in different roles dates back a long time. And the very first time was we organized EpiRob, which was epigenetic robotics that until some time it was then joined with ICDL. We organized that in Genova, and that was my first, organization of this conference. But then we participated in 1907 in London. And then 2013, this was in August, I think it was Osaka, with my friend here, Minoru Asada. And then we reorganized ICDL EpiRob, which were the two titles were together in Genova in 2014. And I just I want to list here the invited speakers of that version, which were chosen by myself and Masako Miyawa. We were bridge chairs, because we both like to mix different communities, which is the main goal of ICDL. And the last one as a participation was 2016. I've been in the organization many times, and I want to break, let's say, to emphasize that I was general chair of the 2020, which was, in all this graph, it was this low, and that is not because of the organizers, they did a fantastic job, but it was the year of the COVID. And the conference started, to be organized there, but then it was became a mixed thing. So the numbers are low because of that. So let's go to the talk then. So what is the goal here? I will try to revisit some of the initial objectives of developmental robotics with the goal of ending by suggesting some areas of research which to me needs maybe a little bit more emphasis than what it is done now by our community, including myself. So that's I want to stress. When I will talk about, I will say we did or our approach, I take full responsibility as one person. So I don't want to. So anyway, our approach more or less, is this one, as Alessandro was mentioning at the beginning. We started working with, developmental robotics, a few years ago. Let's say few now, and the idea here is, as she was saying, is to study humans, to build robots, and use robots to study humans. Basically, it's a virtual circle which have paid a lot for the evolution of the field and the evolution of my perception of the field. So we started with this idea of why development, and that was because at that time there was this engineering view that if you want to build a complex system, the first thing you have to do is to break the system apart. Okay, this is of course not. Now we know very well. This is of course not a good way to go. And because the nice things about the developing system is that it is a system every time. All along the life of the biological system, and everything is very nicely, they lock very much one to the other. So you don't see very well, but you don't move very well. But you move exactly in the way that allows you to exploit the vision that you have. So it's a very nice engineering issue, And as an engineer, looking at someone else building a system, it's like going to the factory, the factory of the mind, and see what is going on. So, and I want to mention right away the fact that during the evolution, I had a few persons at that time that were really contributing to the idea of how to build a developing system, and it is a very mixed mix of knowledge, and these are the people I want to mention here. So what we were doing now at that time was, looking for the magic sequence. For example, how eye and head coordination develops. And, Klaas van Osten was doing very nice experiments in that, for example, this just mentioning this one, recording tracking of a target by children. 3 months old, they basically move only the eye. At 5 months, there is a coordination between eyes and hand. Eye and head. So we tried somehow to replicate this by saying the magic sequence. Well, you start with some abilities that you already have, and then you develop how to control saccades, and then you develop how to control the neck. Neck is a big muscle; it requires some more expertise than the eyes. So this was what we tried to call the magic sequence. So how the development of things interleaved one to the other. And we did things, like learning to control gaze, of course, learning gravity. In this particular case, the robot was learning his body map. In fact, it is tracking targets, let's say, with the eyes closed after he has thought about that. And then, the effect of actions. And these were very interesting. We enjoyed them very much. But there is a problem here. There is a problem with fragmentation. The system is typically focused on the acquisition of just one task on one side. And we implemented what I call a stroboscopic view of development. Freezing a given time, the evolution at a given time during development, which is exactly the opposite of what development is. It's moving from one situation to the next one without any interruption. So that was a big problem that we have, and that you will see that we still have this this defect. But anyway, and the other thing we did, we underestimated the role of social interaction. You cannot do everything. So we started with sensory motor coordination mostly. Then, as Alessandra was saying, there was this robot cab project which had two targets, to create the iCab, a physical platform to be shared with other researchers, but also to study cognition and understand, the meaning of gesture and so on and so forth. And I'm putting up this picture because, RoboCab and iCab, contrary to what is the general opinion now, that it is the IIT humanoid, initially and now is not the IIT humanoid. It's a humanoid of a group of people that you can see in this picture. Some of them I'm sure you recognize. It was a fantastic group. And I take, one of my one of the achievements that I consider as the big achievement is being able to put together these people, and it was to me it was the best project I had, and I had a few, by the way. But so exactly when RoboCab started. And the iCab was half built. I was involved in the foundation of IIT, having to write the scientific, the part of the scientific program devoted to robotics, and which is synthesized in that picture there. It was human, humanoid, and the interaction. So trying to expand into IIT the RoboCab group, let's say, the knowledge of the RoboCab group. And, it was basically, I will not enter into details, of course, but it was the focus, it was on ontogenetic development. And you can see here a list of abilities, from month 0 to month 13, which was sort of guiding our research. And this was the time that, Alessandra entered into the group as a young student. But anyway, the goal here was to, the axis of the development was increasing the complexity in action space and increasing prospection. So that is the issue that we considered important. Prospection is the core of cognition. So how did we do? Well, we did very well. We did a lot of very interesting, to me at that time, but also now, very interesting experiments with the iCab. But still, it's a fragmented collection of abilities. Each one is interesting, but a collection is not a system. So we are still missing this aspect here. And we needed to realize that we needed to focus more on social relationship. So we started by exchanging, studying how to exchange gestures, but it was just a very superficial level. Well, Aude Billard was already working on imitation learning, so it was there in the project, but at least we did not focus on that very much. So, in order to sort of try to go ahead a little bit, we moved from using the robot as a model to using a robot as a stimulus. Studied the principles behind human interaction by using a robot where you can control very precisely the trajectories, the velocities, to see which parameters are the parameters that are important to convey information from one people to the other. And this is a teamwork, which is now the team that Alessandra is leading. I'm there in the back, and I'm very happy to be in the group. And Dario Pasquali and Marco Fedozzi and Sara Mongile, who are here today and did their presentation here, are also part of this group. So put ICAB in the loop with humans, and focus on two roles of actions, not only actions, not only executions, but also communication. Exploit the fact that when you move, you communicate, and you communicate messages which can be implicit or explicit. Somehow implicit are, for example, through the elasticity of our muscles, to the space variant resolution of the retina. All these parameters, which are bodily kind of parameters, actually affect how we communicate. And to communicate, we use a full set of messages that I will not enter much into the details, also because in this group and in 2025 we are already well aware, and you are already well aware of this. We spend some time in testing it, on the humanoid also, detecting biological versus non-biological motion, exploiting gaze for interaction, what you can use, the gaze for, the velocity profile of when you act, which can tell you, the weight of the object the person in front of you is manipulating just by the, let's say, not the trajectory, but the velocity profile. This idea of motor contagion, the architectures and the style of actions. These are just snapshots. Now the group with Alessandra is addressing even more, let's say, high-level aspects like trust and emotion and so on and so forth. So how are we doing here? What is, we have not delivered the system we promised. I mean, that is, that is a usual outcome in research. But we have shown that building artificial systems can be useful to understand humans. And just a couple of examples. I mean, with the RobotCAD project, people think always about the results, in robotics field, but there were also results in the scientific areas. Klaes van Osten and Luciano Fadiga, they came up with new experiments discussing with people building robots what was important to do. And we are continuing to do that. We study humans on one side, and we implement what we study there and it is a bidirectional flow. So if you are able to establish this bidirectional communication, then it works. Otherwise, you get advantages, but it's not really building up very much. So we have a collection. We ended up with a collection of very very nice behavior. What is the problem here? The problem is that the system does not scale. If you take each one of them, it's very good, it's very nice. But this approach does not produce a convergent science. Everybody's still working on, and unfortunately, from one side, is that bodies evolve faster than minds. This is probably obvious. A mind is much more complicated than a body. But we do have these fantastic bodies, of robots that still don't know what they are doing, and they are not understanding. They don't understand, basically, just puppets. So, why robots still do not understand? Well, on one side, the answer is very easy, because we don't know enough about human cognition. So forget about building an artificial system, and the mind is very difficult. The other one is that, I think we invested more time. When I say we, I say, in the world, I don't know, very extensive. We invested very much in bodyware and not very much in mindware, at least from the engineering point of view. The engineers like to build things, to build physical things, But I think we underestimated the importance of how to implement the machinery of the mind. So the physical system that, I don't know, let's say replicates the brain, in very large sense, or replicates the nervous system in a very large sense. Because we have, I think, again, and when I say we, I say me, okay, I don't take, but anyway, the role of imagination and dreaming in our mind. What kind of knowledge to start with? This is an innateness issue, and the structure that is the embodiment of the mind. We talk about embodied system, but it's not only the body itself. It's not only the muscles. It's the mind is also embodied. So the role of action imagination, I like Italo Calvino. It's an Italian writer, but it's also an Italian scientist, that he was talking about action imagination, in fact, which is a basic human faculty, the power to bring vision into focus. You can imagine actions even without... And this definition of imagination is a sort of a tongue twister, but it's very nice. I let you read it. So this is a writer. What about science? Well, about science, there is the other side of the coin. This mental simulation theory that was proposed initially by Marc Jeanneret, where real movements are consequences of covert internal simulation. And the simulation and the generation of movement share the same cortical and computational basis. Okay, the same system simulates and executes. So intention, imagination, and experience, that helps you to go beyond the action perception loop, which is embedded into the very nice bodies that I have shown you before. So what is this? I think is the machinery, supporting mental simulation and prospection, and that, the fact that you can emulate and execute action is an excellent illustration of, as Pak said, of cognitive synergy. So it's a contribution of many systems. Maybe it's also the machinery of dreams. We dream. And we see and we live, sort of think we are living something real, but it's not real. But in your head somewhere, there is a mechanism that generates this, and simulates. And the role of dreaming is also another important. So is anthropomorphic embodiment, basically. What I say is that the concept of a chair is not a shape, is an action. If you think about that, and the mirror neurons, I will not talk about mirror neurons, but they change my view of how an intelligent system is built, and we understand the others using this internal model that I was referring to, and which is a very crucial. There are actions and research in that direction in the field of predictive coding, which dates back, by the way, 1997, Rao and Ballard. So it's a very old concept, but still very, very important to me, and active inference, which is also. So it's the idea of learning to anticipate the next sensation, what you will feel, perception from inside out, I call it. So which role for big data? I have spoken already 45 minutes. Wow. Okay. Well, let me go faster. Big data. Well, I'll skip the big data. The limit. What I say is that the limit is not on learning how to use a tool or how to reach a goal, but on the ability to find new uses for a tool or new ways to reach a goal. That's intelligence. You're not learning about how to use a hammer. And what about the role of generating a large language model? Well, for me, it's too early to say. What I see is that there are interesting correlations. Language evolved from gestures, not the reverse. So there must be a relationship there. And we share areas in the brain which are used to act and to speak. Broca's area is a sort of a syntactic area that drives actions and language. And there are models, talking about generative grammar of actions. In an old project called Poeticon, Caterina Pastra and Yanis Aloymanos presented, this idea of generative grammar of action. But for now, LLM produce experts in saying without understanding and describing an action does not mean knowing how to perform it. We have these sentences, easier said than done. That's one thing. So, and learning to perform an action requires more than observing an action. You can learn a language by reading a book, but you cannot do actions by watching TV. Really true understanding requires embodied experience and the sensory motor grounding that humans rely on. So this brute force approach, that was claimed by Jensen Huang, the amount we need to create the foundational model. Well, the amount, and it said, the amount of computation that we need is incredible. What he was thinking about was, in fact, the number of CPU boards that you can sell is incredible. But, the method involves constructing a physical model of the world, but the goal is not to build a model of the world, it's to build a model of the interaction with the world. So you need to touch. And I will skip this, analogy with the Library of Babel by Jorge Luis Borg, which was thinking about a library with all possible books. We are thinking about, this idea of deep learning and and LLM is to think of building a library where you have all possible movements that can be done. That's not. You don't need more data. No, you need more doing. In a very short sentence. So we need to shift from data to embodied interaction, from describing the world to engaging with it, from infinite libraries, to finite and meaningful experiences. How to reconcile the role of internal models and external data? Well, I think one way is to looking at the time scale of adaptation. After all, evolution, development, learning acts at different time frames. A different time in our life, millions of years, weeks, years, days, for young kid. So the intelligence, which is what we are interested in, is the results of the convergence of various mechanisms. that operate and continue to operate, with different times and ways, So what kind of tools do we need for evolution? Epigenetics, development, learning. Maybe it's the old issue of nature and nurture, but epigenetic, I think the fact that it disappeared in the title of the conference, I didn't like it very much, because I think, is the interface between evolution and development is there, and it is a very important time in life. Let me skip this, because what I want what I want to say is that the tools for deep learning may be useful to implement the evolutionary part of the process. What you have at time zero, and the important contribution of evolution is embedded in the morphology of the system, encoding this core knowledge. And this is the concept of core knowledge that Elisabeth Spelke described, in all her life, but particularly very much in her latest book, and these are sentences from the book. I believe the core systems provides the foundation for the abstract concepts at the center of our explicit knowledge. And the important thing of this is that the core systems are astonishingly ancient, she says, and are shared by animals as remotely related to us as chicken and fish. So there is something there in common. What do we have in common with a chicken? Maybe that if we study that, as Valdo Lortigara is doing in Trento, we will understand what are our innate abilities. Innate is a tricky word. I know that it also always generates a lot of discussion, but it's the same mechanism, maybe the same mechanism that supports us dreaming. And there are this idea that that babies in the womb they dream, to see what they can do somehow, as Yasuo Kuniyoshi has been studying very much. So maybe we have been focusing too much on innate reflexes and not enough on innate knowledge. That's one of the things. And to do that, we need a reference. And what kind of reference do we need? Calvino said that we need the imagination machine, which you can read his description, which is very interesting. Scientifically speaking, what I say is that we need cognitive architectures. We need to think about the structure, the machinery of the mind, which is what I call, and we need to start converging studies between the structure and the function, which we still, some of us are doing it, but I think that is important to take into consideration the structure that we share with other animals and see what, and maybe we are using machines with von Neumann architectures. They are not very good for doing this, unless you put a lot of energy inside. So sometimes I ask myself if we are trying to empty the sea with a colander, trying to solve intelligence using computers, or computational systems. While in neuroscience there is this idea of studying the embodiment of the mind by analyzing the correlation between the structural and the functional connectivities. And there are regularities there that people have shown. So I think we need to put together a shared project, to study the convergence of real-time control and proactive simulation, convergence of innate knowledge and acquired experience, optimization method and intentional, transparent decisions guided by values, convergence of research communities, to study the relationship between the structure and the function of the mind. We need to foster the formation of this extended community, and I think that ICDL, it's a very important, I would say it's a unique. There are other conferences which, resonates with what we are interested in, but ICDL is certainly the one that addresses this very much. So last slide, a summary, So I've been talking about action, execution, and imagination, big data and the timescales of adaptation, relationship between structure and functions, innate reflexes and knowledge, and this need for a convergent research in an extended community, which is what is doing ICDL, basically. And with this, I thank you very much for your attention. Thank you.
Thank you very much. And now we have time for questions.
No, we don't have time. But we can pretend to have time.
So I see one there.
Well, first of all, thank you for your presentation. It was very interesting. And in particular, I would like to comment on your point that you made in terms of imagination and how to understand imagination or dreaming for systems and what role it plays in learning, perhaps also in absorbing all the information that you have and then producing new outcomes. I remember also that Professor Gottliebson in the US is also saying that an understanding of the self also involves imagining yourself in the future, which is somehow a very unique ability, at least in humans. So I would like to also see what is your take on this in the sense of what does it mean to imagine. We see also in reinforcement learning when they have this curiosity-driven exploration on intrinsic motivations where you have the prediction as a reward just to see how far along you see in the future and whether it matches your expectation. I guess somehow it's also within the idea of active inference, comparing what you expect to what you see. Yeah. So what would you say, what sort of methods that we have right now sort of fit this idea of modeling how we dream or how we imagine and project ourselves in the future?
Yeah, I mean, as I was mentioning, there are research areas which are going in that direction. This active exploration and proactive, proactive inference. So it's not, of course, a new view. What I think, however, it has to be exploited at the developmental level. Initially, that could help, which is, to my view, it has not been addressed enough. At least in the examples that I've shown and in the examples that I see other groups doing. Even, of course, there are people working. Yuki Nagai is working in that direction, and there are other groups in the world which are addressing this. I think that what is missing maybe is the starting point, what is still missing in an explicit way. So where to start from? What it is that a chicken has in common with a human, in the fact that the structure of the brain is not so different. Of course, we have the cortex, and maybe analyzing what the chicken has in common with the human, and then going and study development. Maybe it will tell you really how to exploit this starting position, So nothing is new. It's just the weight that you give to the different aspects, and the fact that I feel, at least in my mind, I have underestimated the time zero stuff. We assume that a baby recognizes maybe faces, it has some reflexes, But if you talk about reflexes to developmental psychologists, sometimes they say, there are no reflexes. There is something different in the brain of a kid, and if you see a few hours baby, exploring an object that you give in his or her hand. Maybe it is a reflex, but maybe it's not. Maybe it's something which is just starting to work. The connection of subcortical with cortical areas and so on and so forth. Sorry, long answer. Thanks for the question.
Okay, there is still time for question. I saw one there.
About the convergent research in an extended community.
Yes.
So you certainly remember one of the big failure of the European research community, so the famous flagship project
Yes.
of 10 years ago.
The
So
brain,
do you think that
human brain project, you mean?
no, I mean the Robocom. No, human brain project. Was another kind of failure.
Okay. Yes.
No,
I think.
But the question is: so you do you think that this could be one thing? Is for sure is growing ICDL, adding back EP,
epigenetic, EP something.
You also think. What do you think about the idea of the CERN? For embodied AI, following Parisi. It's a big research center where you put people and you really try to force. It's a bit VAT maybe. But
I don't know. I mean, I personally prefer a more, dynamically adaptable system. If you establish a big center somewhere, then, if you want to change its content after 3 years, it's an incredible work. I see IIT, 25 years after we started, it's a different place. Not exactly like the one I was thinking about, but, it's very hard to change the structure. You have tenured people, you have, publications, you have labs. So I would prefer something a network more than just one place, or a network of places, let's say.
You mean growing ICDL, for example, or similar companies, or you mean a kind of network program like was
Well, networks are very interesting. I mean, my experience of Robot Cab was fantastic. If you put together bright and nice people with whom you share the long-term goal, that's a key part, then that's working. And it has been working for 5 years. If it was 10 years, maybe it would not have been as nice, because you have the tendency of continuing to go on with so sometimes you need reshuffle the deck of cards, and see what is something out. So and ICDL is important, I think, because at least to me, the important ingredients are all present, and sometimes there is one which is overrepresented, but it is a dynamical system. So, but you need to keep the goal. Very not focused, but I mean this idea of development is so strong that we need to keep that in mind. We want to dynamic systems that change,
Okay, I saw a question there.
Thank you very much. You highlighted in your presentation the importance of developing science and developing communities and also developing people.
Yeah.
So my question is a bit general in that sense, but since you have done it so well in your long career, what's your secret for developing people? Which, as many of us, starting career, it's an important skill.
Well, Lorenzo, the secret is to select good people. That's the secret. Then, of course, I mean, in all groups, not everybody is a star, and it would be not a very good educational procedure to just educate, the stars, So you need to be able to also have around people who are not, let's say, the stars. But the real continuity of a research is through people who actually feel the same long-term goal, and they feel, they are not asked to do, they feel the long-term goal, and they are ready to bring it on. So if you don't know, if you don't have time to do what you want, be sure that you leave behind you someone who continues. And that is only through bright people. Yeah.
Okay, the very last question.
Yeah.
Thank you for the great talk. I
Thanks.
completely agree with you 200% or 300%.
I know, Minoru.
So one of the issue is that just you say human.
Yeah.
But human, so many variations, especially the cultural difference is one of the key points.
Yeah.
For example, the Western people and the Eastern people, think about the individual or the independent or dependent. It's very big difference.
Yeah.
Therefore, how to cope with some social interaction.
Yeah.
So of course, I don't have any answer.
Yeah.
But do you have any idea to cope with this kind of cultural difference, or maybe gender difference, or something like that?
Yeah. Well, this is the reason why I think the epigenetic period is fundamental, because that's to me, maybe it's not so simple, but this is exactly the period where you establish these sort of cultural differences. At least I have this idea that the brain is equal, in a Japanese infant and in Italian infant. But during the first months of life, they live in a different environment. And these steers, the things. After a year, I think it would be impossible, maybe not, but maybe very hard to transform a Japanese infant into an Italian infant, or vice versa. That is the reason why in the epigenetic phase you can really see, how systems can evolve, in development.
Thank you.
Thanks.
Unfortunately, the time
Thank you.
is over. So a big
I'm
round
here,
of
though.
applause.
Thanks. Thank you.